All right, so we're going to do this problem just using normal multiplication rules. So that in normal multiplication rules, we're going to take this -3, we're going to multiply it to -1, we're going to multiply it to 5t, and then we're going to do the same thing with the 2t. So what's -3 times -1?
3.
3. And that's a positive, so I'm going to put +3. What is -3 times 5t?
-15t.
Okay. All right. So then in normal multiplication rules, we put a 0 or a placeholder there, right?
Mm-hmm.
So then we're going to do the same thing with the 2t. We're going to multiply it. So what's 2t times -1?
-2t.
2t times 5t.
10t. Or would it just be 10?
Well, 2 times 5 is 10. We also have to do t times t.
So 10t.
Well, t to the first times t to the first. So you have this. So t times t is t to the what power?
Second.
Yeah, it's t to the second power. So when you multiply monomials, you add the exponents. So it's t to the first, t to the first. 1 plus 1 is 2. So there we have that. And so now we have to combine the similar terms. Do we have any other t to the seconds?
No.
No. So we can't combine that with anything. -15t minus 2t is?
-13? No, -17.
There you go. 3 plus 0 is?
3.
And that's the answer.
Okay, that makes sense.
Yeah. So you could also write this problem like this. And I gotta tell you, almost 100% of the time, you're gonna do the multiplication horizontally, not vertically. So if you don't fully get this part, it's okay. You can write it horizontally like this.
Okay, that makes sense.
So rainbows and smiley faces. So the rainbows and the smiley faces just denote distribution. We're distributing these values distributing the r to both terms inside the other parentheses. So what is r times r?
R to the second?
Yep. What is r times 6?
6r.
That's a positive, so I'm going to put plus 6r. All right. -3 times r.
-3r.
Yep. -3 times 6.
-18.
There you go. R squared gets brought down because there's no other r squared. What is 6r minus 3r?
3r.
3r. That's a positive, so I have to write plus. And we just have the plane 18. And that's it. Would you like to do some more?
Yeah, can we do a couple more?
Sure. All right. Do you want to pick some more from here, or do you want to go to the other sections?
Let's go to the other sections because I think I pretty much understand this one.
All right. So for number 20, same basic principle applies. We are distributing the x to everything inside the other trinomial. And we're also going to multiply everything to here. All right, so why don't you take it away?
Okay, so would we do x times x to the second, which would be x to the third?
Yep.
Okay. And then x times 2 is 2x. So plus 2x.
Hold on a second. X to the first times x to the first is x to the...
Oh, x to the second.
There you go. Okay. So since there are a lot of them, I'm just marking off the rainbows that we have done the multiplication with.
Okay. And then 4 times x would be 4x, right?
Yep. Okay.
Then 3 times x to the second would be 3x to the second?
It would be.
Not quite sure.
Yeah, you're totally right. And notice how I'm writing the x to the seconds directly underneath each other. That way it's a lot easier to add them when we're done.
Yeah.
Okay?
And then 3x times, 3 times 2x is 5x.
3 times 2 is...
6.
That's an easy one to mess up on, no worries. Because you're adding the exponents, but you're multiplying the numbers. I totally get it. All right, so that's 3 times 2x is 6x. Okay.
And then 3 times 4 is 12.
All right. All right, so let's combine the similar terms.
So x to the third is by itself. And then 2x plus 3x to the second would be 5x to the second.
All right.
And then plus 10x plus 12.
And that's it.
Oh, okay.
All right, so for 28, this actually is a big idea that's going to be coming up later. So what is the distance from this to this? If I were to walk this distance, how far would I walk?
2.
That is an A.
Oh.
So-
I don't know.
Neither do I. So let's call it A.
Okay, so you'd walk
A, whatever.
AB.
Okay. So then, if I then walk this distance, what would I be doing with A and B?
Separating them?
But if I was walking from this corner to this corner, and I walked A and then B,
Adding.
I'm adding them. So this whole side length has a length of A plus B.
Okay.
What does this side length have? And if you're just joining us for class, my goodness, I would take notes if I were you.
C plus D.
Yeah, C plus D. So the area of this whole thing, can be described as base times height, or C plus D times A plus B. Oh, does that make sense?
Yeah.
Now that looks like the problems we did before. But
Yeah.
what is the area of just this rectangle right here? So yes, you should be taking notes if you just arrived. What's the area of this rectangle right here?
A times D.
Yeah, so that's AD. Oh, well that's the same thing as saying A times D. Okay. What's the area of this rectangle right here?
CA.
CA. Very good if you're Colorado Academy, but we're going to go alphabetical order. So AC. So, and here's our AC right here. So we have AC plus AD. Okay. What's the area of this rectangle right here?
BC. Oh. BD.
BD. So here's BD. What about this last rectangle right here?
BC.
Oh, well, that's the same thing we did just there. So the area of this rectangle can be written in this form here. This, by the way, and this is a little bonus. This is in factored form. And so this area is in factored form, and it's equal to this area right here, and we call this expanded form. So this is just foreshadowing of great things to come. All right, I really appreciate your joining me for office hours and the questions that